Hey guys, welcome back. I'm going to talk about the house robber problem today on LeetCode. It's a pretty straightforward medium dynamic programming problem. Um, let's dive in. Uh, if you're not familiar with dynamic programming, simply put, it's a method for solving complex problems by breaking them down into smaller subproblems, solving each subproblem just once, and storing its answer in case we need it again later. It's kind of like saving your game progress so you don't have to redo levels. So, the house robber problem uh, simulates a scenario in which you're a house robber uh, and there's a street of houses, each with some amount of money stashed. You're a house robber, but there's a catch. You can't rob two adjacent houses or else you'll trigger an alarm. So your goal is to figure out the maximum amount of money you can steal without setting off any alarms. In effect, you just need to avoid robbing adjacent houses. So the brute force way is to just try every possible combination of houses to rob. But that's just not good. It'll take 2 to the n combinations to check. And we want to avoid that and reduce time complexity as much as possible. So we can use dynamic programming to store the maximum amount we can rob up to each house index. So for example, we calculate the solution considering array 0 through I. The solution only considering 0 through I of the array up to the ith index. So up to the 0th index, up to the second index, up to the third index, up to the nth index. And we'll notice that if we can calculate all those solutions up to the I minus 1th index, it's very easy to calculate the solution for the ith index. In fact, we just need to take the best solution from robbing the current house and the solution from 2 houses before, add them together, and compare that with the solution from just not robbing this house at all, and only considering the last I minus 1 indices. Because those are our 2 choices. We only have 2 choices when we're at a certain house. We're going left to right, and at each house we can only choose whether to rob that house or to skip that house entirely. And then if we skip that house entirely, we get the advantage of being able to rob the adjacent houses. So with this in mind, we can formulate a very clean solution. This is a guard to protect against an edge case where the length of the array is very short. If we only have 2 or less houses, we just choose the best house available, because if we had 2 houses, then we would only be able to pick one. And if we had 1 house, we obviously want to rob that 1 house. Now, at any given point, we only need to consider the solution from I minus 2, which we call prev, the previous solution. And we also want to store prev, which is the solution from the last index. So at any given point, we have in our memory the solution from the last index and 2 indices ago. Now, starting from the second index and going to the end of the array, we update our variables accordingly. We choose the best option at our index, like which we said earlier, is robbing the house, gaining the value inside it, which is nums I, and adding it to prev, which is the best solution considering up to I minus 2. Or we don't rob the house at all, and we just take the solution from I minus 2. And then, since we advance 1 position forward, prev becomes prev, and our previous value is actually our current value, and then we loop back again. And at the end of the loop, our previous value will be our final calculated value, so we just return that. Now, let's submit the solution and see how it goes. You'll see it beats 90% of solutions, 70% of users with Python 3. It's pretty good. I've solved this problem. Wow. Okay. Yeah, it's a great solution in terms of both runtime and memory. So I hope this taught you a little bit more about dynamic programming and gave you a bit of an intuition for how to solve these kinds of problems.